So in this section, we are going to compare expressions with exponents. And the key here is we want to look at the exponent when the base is the exact same. So this first one says write 4 expressions that are equivalent to 12 to the 2 to the 13th power. So a popular one here is when we multiply like bases, we know that we add our exponents. So this expression right here equals 2 to the 13th power. Another multiplication one, let's go with, 5 and 8 also equals 2 to the 13th power. When we divide like bases, we subtract our exponents. So we can go 20 and 7. Now, power to a power is a little bit difficult here because there's only one way to multiply to get 13, and that's 13 and 1. So we can just put 2 in parentheses to the 13th power because we know that that's 2 to the first power, and we will distribute the exponents to multiply exponents by exponents. So here, which expressions are equivalent to 5 to the 8th power? Well, here, multiply like bases, we should add our exponents. We get 5 to the 9th, so that is not one. Multiply like bases, we add our exponents. This gives us 5 to the 8th. That is one of them. When we divide like bases, we take the numerator in the exponent, subtract it from the numerator or from the exponent in the denominator, which gives us 5 to the 14th, which is not 5 to the 8th. So that is not an answer. And when we have a power to a power, we distribute our exponents and we get 5 to the 8th power. So there we go. Okay, now let's compare which side is greater. Well, on the left here, that's already done. There's nothing for us to do. So we're going to leave that one alone. We have on the right, we're multiplying, we have like bases. When we multiply like bases, we add our exponents, which gives us 3 to the 5th power. Now that we have both sides simplified, we are going to look at the exponent. Since our bases are the exact same, both bases are 3, we look at the exponent. Since we have a whole number here, our exponent, the larger exponent, is going to be the larger side. So 3 to the 6th is greater than 3 to the 5th. So on this next one, I see that my bases are all the same. That's good. On the left, 7 to the 4th, I'm going to leave it alone. On the right, when I divide like bases, I take the exponent in the numerator, subtract it from the exponent in the denominator, which gives me 7 to the 4th power. So this side equals 7 to the 4th power. Since I have like bases, I compare exponents, and in this case, my exponents are equal. Down here, power to a power, okay? I'm just going to leave it as 1/4 to the 16th power. In parentheses, that is fine. Here I am multiplying like bases, right? 1/4 and 1/4. When I multiply like bases, I add my exponents. And this gives me 1/4 to the 10th. Now I have the same base. Now I have 1/4 and 1/4. They're the same base. So now I need to look at the exponents. One is 16, one is 10. Everyone knows that 16 is bigger than 10, but we need to be careful here. And on these types of questions, most students just look at the exponents and move on. Here we have a fraction. We don't have whole numbers. So when we have fractions, fractions are actually opposite of whole numbers or integers, where the smaller the exponent, the larger the number. So in this case, 1/4 to the 10th is going to be larger than 1/4 to the 16th, and here I will show you why. 1/2 squared equals 1/4. 1/2 times 1/2 is 1/4. 1/2 to the 3rd, which 3 is bigger than 2, is 1/2 times 1/2 times 1/2 equals 1/8. Which one is bigger? 1/4 or 1/8? The answer there would be 1/4. Therefore, the smaller exponent is actually a bigger number when it comes to fractions. Let's simplify. All our base numbers are the same, so I'm leaving 9 to the 12th. Here, I'm dividing like bases. When I divide like bases, I subtract my exponents. I get 9 to the 33rd. Since my bases are both integers and they're both the exact same, I look at my exponents. 33 is bigger than 12. 9 to the 33rd power is larger than 9 to the 12th power. So here we go. Now we have two sides, but we don't have the same base everywhere. On the left, I have a base of 3. That's good. It's only one expression on the left, or one term, I should say, on the left. I've got two terms on the right that I'm going to need to simplify. But first, I want all my bases to be the exact same. The only base that is different is this 9. I need to think, how can I turn this 9 into a 3? What's another way to write 9? Well, let's start thinking about what we can do to the number 3 to get 9. If I take 9 and I do 3 squared, does 3 squared equal 9? Yes. So here, if I do 9 to the 10th, that's like saying 3 squared to the 10th power. These two expressions right here, these two terms, are the exact same. And then I'm going to multiply by 3 to the 3rd. When I have a power to a power, I distribute and multiply my exponents, so this gives me 3 to the 20th power times 3 to the 3rd. And then I should add my exponents because I'm multiplying like bases. I get 3 to the 23rd power on the right. Since both bases are the exact same and they're both integers, I should look at the exponents. 23 is greater than 18, so 3 to the 18th is less than 3 to the 23rd. We'll try to slow down here a little bit, okay? So I'm going to look at my bases. They are all different. So I am going to look at my smallest base, which is 2. I want to rewrite all of these numbers to have a base of 2. So if I have the number 4 here on the left, how can I rewrite the number 4 to have a base of 2? Well, 2 squared equals 4. So really, all I did here was rewrite 4 as 2 squared. And then, this is 4 to the 21st, so this is going to be 4 to the 21st. Now simplify even more. Exponent to an exponent, we multiply our exponents. 2 to the 42nd power. These are very large numbers. A lot of students want to just plug these into their calculator, which is a great idea. But when you get these really super big numbers, your calculator is going to put it in a term in a way that you don't quite understand. It's called scientific notation, and we haven't learned how to read that yet. So it can be confusing for a lot of students. So here, if we can just break it down and just compare exponents, that's the easiest way to do it. This 2 to the 28th, that is already in base 2, so I'm going to leave that alone. Now I have the 8. How can I rewrite 8 to have a base of 2? I know that 2 squared is 4, so that doesn't work. 2 squared doesn't work. So let's try another 2 with an exponent. Well, if you type 2 to the 3rd in your calculator, that equals 8. So another way to write 8 is 2 to the 3rd power. And then we take, so this is 8 to the 4th, which we have 8 to the 4th. Power to a power, we multiply. So I get 2 to the 12th. Now when I multiply like bases, I add my exponents. 28 plus 12 gives me 2 to the 40th. Here I have like bases. They're both integers, so I then compare the exponents. And I know that the larger exponent is the larger number because they're integers, or they're whole numbers. 42 is larger than 40. All right. All three bases are different again. So let's look at the lowest base of 3. Can I rewrite these to have a base of 3? I'm going to start on the right side this time, because as we did in a previous one, there's another way to write 9 with a base of 3. 3 squared is another way to write 9 because 3 squared is 9. So we can rewrite it in a different way, 3 squared. So here in parentheses, I just have the number 9. And then I have to take it to the 8th power because that's what's in the question. On the bottom, I'm going to keep 3 to the 4th. Let's simplify the top. Power to a power, we multiply our exponents only. I get 3 to the 16th over 3 to the 4th. Then when I divide like bases, I subtract my exponents. 16 minus 4 equals 3 to the 12th. That's on the right. Now let's go to the left where there's 27. So I know 3 squared is 9. Again, I want to rewrite 27 to have a base of 3. 3 squared is not going to work because that equals 9. But 3 to the 3rd power is 27. So 3 to the 3rd power is a fancy way of writing 27. All of that to the 5th because the question says 27 to the 5th power. Power to a power, we multiply. 3 times 5 is 15. So this is 3 to the 15th power. I'm comparing whole numbers. I've got like bases on both sides, and they're both whole numbers, so I can compare my exponents. 15 is larger than 12, so 27 to the 5th will be greater than.